All right, cool. Welcome back, everyone. For those who are with us with our deep dive, I assume you're the same people who are watching this. If you didn't do that, but you're doing this, then interesting progression there of technical complexity. But ultimately, what we're looking to show you here is building a very simple node in the Flowgear environment. So what that's going to look like is taking you through some of the foundations of what that would require. We are effectively a Microsoft shop. In other words, we build onto the .NET platform. And so the foundations or the requirements thereof will involve building within some kind of C#-based IDE, and at this point, a minimum of .NET Framework 4.8. That's going to be the basis for your project. Beyond that, we're going to use an SDK to actually interface with Flowgear, but at that point forward, it's really just design principle from C# side of things. So we'll be doing this live build, and then we'll be transitioning to relevant areas of design, which are going to take you a bit further into what are some of the important things to factor in when building a node. So this is very simple, this is very lightweight. I think I have the use case here. We'll be doing file transactions from a computer into the Flowgear platform. So the idea is that this node is going to be able to read and write files from a machine, and that will be the basis for what this use case is going to look like. Beyond that, what we'll then do is go into some of our more complex nodes, not in depth, but just to give you an idea of how some of the other touch points in designs or relevant areas of designs are, where we can, for instance, interactive elements, so where else does the console touch the engine? And where else we could apply error handling, configurations, authentication, and samples. So a lot of that's not going to make too much sense at this point, but I'm going to hand over to Rick. Rick's going to build this out. I'll give a best possible explanation as possible while he's busy doing it, and then we'll touch on some of these things over here as well. So cool, Rick, off up to you.
Great, thanks.
Cool.
All right, cool guys. So yeah, we're just going to jump straight into it. So I'm just going to start up a new project in Visual Studio. So for our purposes, we're going to create a class library. And I'm just going to call it file demo for our purposes today. So at this stage, I'm going to select net6, but we will update this in the project file, as we kind of prefer working with the new project types, as it is easier to reason about and manage, and also just is cleaner for us in-house. To do that, I'm just going to edit our project file. I'm going to update this target framework to net48, as Nick mentioned. I'm going to remove our implicit usings because we actually would like to define and reason about the references we actually have. To allow nullable enable, we're just going to add a lang version of 10, as this is the minimum required for this nullable enable. Okay, correct. Now that we have that going, I'm just going to rename our main project class as well. Also going to call it file demo, so this is also a best practice for us. So the main class would reference your node.
So just a side note there, this is not actually required for the project, but this is again best practice. The parts that are going to actually interface with the engine will come through as we decorate the functions with the SDK's decorators, and you'll see what that looks like in a moment.
One thing I actually forgot that we can actually add here is also the namespaces. We do this so that it uniquely identifies your assembly as well. So to do this, I'm just going to replace this actually with what we have here. So a couple things happen here. Let me just quickly run you through it. So this assembly name is now the assembly, that's going to be the DLL name that's going to be produced as we do the release build. Our root namespace is just the root namespace for this project. And then we have version. So this is very important, as this the combination between your version and your node name is what uniquely identifies a node in the platform. We'll also add a assign assembly. So this is we actually sign the assembly so that we can verify the uniqueness of this specific version. This enforces strict checks so it doesn't load the wrong version. Okay. And to actually create this file demo SDK, I'm just going to open up our developer tools here.
While Rick's busy with that, it's important that you guys bump the version each time you upload. Flowgear is not going to allow you to upload the same node name, same version the second time. And those nodes are also then going to be subdivisioned against the account that you uploaded against. So as an example, you might have a node that you've uploaded in your tenant, but it's not necessarily available to somebody else's tenant. We obviously can publish global nodes, which is what you see when you look at your list of nodes within the list that you pick. And so for you to do that, what would happen there is you would build your node, we would review it, and if we thought, fantastic, this is fit for service, we're going to then upload it globally, which means anybody can then use that node on the platform. That's more for marketing stuff, so if you want your node out in the wild for people to use, that's where you would do that. But I imagine that most of you, what you'll be doing is actually building it for your specific use cases in your environments.
Okay, great. Thanks, Nick. So now I'm just going to use this assembly that we defined here, or we use this namespace. Now we're going to start by decorating our main class to as a node. So we start, before we do that, sorry about that, we first have to actually add the NuGet package for our Flowgear SDK. To do this, I'm just going to right-click on the project, browse, and search for Flowgear. Just going to wait on that a bit. Sorry about that. That's the first.
You spelled it wrong.
There we go. I think it's the internet again, Okay, great. Now let's install this. Okay.
Jokes, guys, we don't have an SDK, we're just wasting your time. No.
Cool. Now that we have that, I'm just going to start by decorating our main class. This would be with node. So you see it's not picking it up, so I'm just going to add a reference to our SDK.
While Rick's doing that, just to give you guys some context here, decorators are what's going to tell the engine what invoke method or what property or any element of the actual design it needs to interface with when something happens on the console side of things. So for instance, the decoration of this class as a node means that when we try and instantiate this object within from the console side, we're basically saying, this is the class that was decorated, here's what needs to then be actually activated, so to say. It's going to be on top of our invoke method, it's going to be on top of our properties, and we'll talk about that in a bit more detail. The actual properties you're seeing that we provide here is, first of all, your internal file node name, which is file demo, your external file name, which is file space demo. Then you also have the type of node, which is going to dictate where in that list of categories it sits. So previously we said, connectors, processors, triggers. That's going to determine where it sits there. Now, the last one for run from drop point only, that's going to determine how your node is allowed to run. So if you do drop point only, you cannot run this in the cloud, so to say. It has to be through a drop point. Alternatively, if you say run from anywhere, then it's going to be as such, where you can run it from drop point or cloud.
Okay, great. Now, what you guys see here is the icon. So we actually need to include that. Sorry, just saying that here. We just need to include this as an embedded resource. So I'm just going to go and copy where that has been built. Oh, sorry about this.
This is what's going to show up on the canvas, by the way. So when you're selecting the node or when it's on the canvas, this reference is what that will look like. On the old platform, we had a limitation for a 16 by 16 image, which made for some very creative icons that were used. Let me put it that way.
Okay, sorry, just getting into this. It was stored into a different location. That's why I was a bit confused on that. So here we have a file demo class. I'm just opening up my other assets folder, as this is where I have my file demo PNG. Sorry about that. Just pasting it in straight in our root project. And if I navigate now back to my main project, you can see it's included here now. Now I can just update the build action to be embedded resource. And now that is done there. Now we're moving on, we're going to create our connection. So the connection will basically, as you guys saw with Nick and Carl's demo previously, in the platform, in the connection screen, you have a list of properties. So this connection class we're going to create now is the direct correlation between the node and the connections. Okay, so I'm just going to add a class here. So we'll call this file demo connection.
This is where you store your credentials effectively, if you had any to store. Now, in the case of this file node, we'll simply have a flag that we can determine how it needs to operate with respect to its behavior. But you would declare any properties that would involve API keys or access tokens or usernames, whatever here. And as you see, Carl's going to decorate this particular property as well. There's going to be, Rick's going to decorate the property as well. Not going to hear the end of that one.
No, you're not.
Effectively, you'll see that there's going to be options for determining what type of property that is, or rather how it needs to be displayed inside of the platform. And so one of those will be in a second showing you that it needs to be text-based or multi-line, JSON, secret. Secret means you won't actually see it. It's just going to be blocked out by little stars. And so that's the other one, and then obviously whether it's an input and output or both at the same time.
Exactly. So for our purposes, we're just going to keep it very simple. So this property is called the create target directory. So on the file right, if the directory does not exist, and we have set this create target directory to true, it will create that directory, otherwise it will throw an exception. So now I'm just going to come back to our main class and reference this new connection we created. Just going to also, sorry about that, also update our namespace on this. It's already been done because I changed the root namespace previously. So now it should be as easy as adding the connection. So I'm going to call it, or the type would be the file demo connection we just created. And then as you can see, we're going to call the property connection. So now we also need to decorate this so that our Flowgear SDK can determine that this is a connection. So to do this, it will also be a type of, or extended type actually. So it is a type of input, so we still would start with flow direction.input, and then we'll have an extended type to indicate that it is a connection and that certain, it needs to be handled differently.
With this type of extended type, you're going to see that surface as a drop-down right on top of the node. So it's telling you that's the connection that you need to select from. You'll also see in the connection there's actually a space to plug in the drop point itself, or choose a drop point. That's actually implicit. It's not something you have to provide. So you'll see in the connection class it doesn't actually exist there because it's there by implicitly.
Okay. As Nick was talking now, we basically just populated some more properties. So as you guys will see, if we populate this node onto a canvas, this would contain the exact properties you see here. So we'll have our action, and I'll get this going now. So our action would either be a read or a write, and we'll surface it, like Nick mentioned, as a drop-down, as it will be an extended type of enum. So to do this, I quickly created the class. So now I'm just going to actually, it has to be an enum for our drop-down. And then I'm going to have it as a read equals 0, right. Okay. Now that we have that, we have our action, we have our path. So if it's read or write, you still need a path to the actual file. And then we also have the content, which, as you guys can see, is input and output, depending on the action you provide. Now we will head on to our main invoke method. So this also requires that you do return a specific property called invoke result, which I'll show you guys now. And then the method name doesn't make a difference as long as it's public and decorated with the invoke attributes.
There's an extension type on this invoke that allows you to actually re-invoke depending on the kind of node that it is. So in this case, it's going to be invoked once, finish, and then move on to the next node onto the canvas. However, there may be the requirement for you to be able to loop through different nodes, or different iterations, such as your for each that we showed you. And so there's a type of invoke that actually allows you to come back to that method and say, all right, I've got to go again and again until eventually it exits based on some kind of logic. In this case, we're just going to do it once.
Okay. And as Nick was talking, I'm basically now implementing our main invoke method, which would be we're going to switch on the action. So if it's a read, we just want to read the contents of the file and store it in our content property. Just hold on to this.
We've got all of this on backup for copy, just in case we have to move it across. I mean, let's be honest, guys, that's how you do stuff anyways, right?
Don't blame me. My first time doing a presentation like this.
Any hard limits on the amount, Rick?
Not in this side of things, no. So from here, if you were to put in a limit, it would be explicitly based on what you've actually coded in here. But we're actually going to move into a concept called configurations a bit later, which does allow you to pass along certain parameters that would be relevant, like your timeouts and stuff. That that could infer that limit.
Right. Sorry about that, guys. Okay.
Got frosty types, guys. Look at that.
Very fast. And it's still not right because I did that. Great. Okay. As you guys can see now, there is one method that's not been defined, but for our read, we're just going to read the text at the specific path into content. And for the write, we are going to check if the file exists at the path. If it does, we are going to actually delete it. So in this specific use case, we are just overwriting it. if you want to, you can have certain handling of this to basically not then delete a file and either throw an error or handle it in a different way. So to elaborate on our connection previously, I'm just going to create this method called ensure directory exists. So this is where we'll use our connection property if it has been set. I'm just going to generate that real quick. I might copy it again. Okay. Great. So as you guys can see here, this is our ensure directory exists. It's very basic, very simple. All we do is we get the file info for the specific path. We check if that directory exists. If so, it doesn't matter. We can just continue and process normally. If it doesn't exist, then we'll check the specific connection and we'll see whether it has been set to create the target directory. If so, we will create it. Otherwise, it means that the target directory does exist and we haven't set the connection up for that. So then we'll throw that exception right there. So this is basically almost ready. We basically just need to return our invoke result. So to do this, this is when Nick mentioned previously, we have extended invoke results if you want a continuation. For our purposes, we're just going to return a new invoke result.
Something that's important to note there is that within this invoke method, we'll actually set the content of the properties right then and there. We don't have to return, for instance, the content back to an engine to say, oh, here it needs to go. Any of your properties that are exposed, like your inputs and outputs, you'll set them right then and there, and they'll obviously then come through when the execution is finished.
Cool. Sorry, just wanted to make sure my SNK we created earlier to sign the assembly is here. Just moving that correctly, because we do require that. Okay, now our main invoke is ready. We're actually ready to publish the node. But before we do that, we are just going to create a test project, unit tests, just to confirm that everything is working as expected. These unit tests could also then be used if you use version control like GitHub and you want automated tests to ensure there's no regressions if you make any new changes.
So there's a couple of layers to testing. First is that what you've written is at least functional on its own as a unit, right? You don't have to have it published into the platform first to try and find proper issues with respect to the logic you've built. However, there are options to, for instance, publish it and then test it within the platform and even run it as a test harness where it debugs through your actual VS or Visual Studio, whatever you're running. And as you click on run on the console, it's actually going to throw back that debug back into your Visual Studio where you can then see, all right, here's where it broke and here's why it broke. Very important because depending on what you're building, there might be security issues around what you're trying to access and how you're trying to do it. So there is sometimes a bit of deviant behavior with respect to what you've built here versus how it behaves on the console. It's not, by and large, it's not really much of a difference, but there are those potentials. With the new platform, before you carry on there, with the new platform, we actually have tenants spun up for each person, so their own VM. So from that perspective, you're not going to really have issues around security there in that you can run basically what you wanted. So for those who do remember the old platform, there was sometimes the requirement to actually allow certain nodes to run. That's no longer the case.
Okay, great. So we're just going to flush out this test class we have here. So we're going to keep it very basic. Just going to rename this specifically for a file read test. Now in here, we want a read test of a local file, and we also want it to return true. So you can have tests that tests for certain exceptions. Yeah, if you would like that as well. True. So in here, first we need to actually also add a reference to our project, to our main node project. So I'll do that, file demo. Now that that's been done, we can start by creating our connection. So first we actually need a path to read the file from. So I'm just going to call it string path. And then
Rick's going to go ahead and hard code a bunch of the stuff if that's necessary. If you're not using a test harness, meaning your credentials are not being stored in an actual connection, what we recommend here, or at least best practice, is when you reference your credentials, reference them as like a JSON or an XML document, serialize it into an object, and then just create that object in your connection here. And then where you pick up that file from should be a generic location within your machine. So when you actually commit this code to GitHub or something similar, you're not pushing across those credentials into the actual repo, which would be a problem, right? We don't have credentials, so we're just going to hard code the path as an example and run it against that.
Great. Okay, so all we're going to do here, it's not used for the purpose of this actual test, but I just want to show you guys how you can actually instantiate a connection locally as well. So there we can set the target directory to true. We won't be using this in this test, but that's how to do that. And then we'll create our actual node. So this will be file demo. And then what I'll also do here is initialize the properties. So path, we're going to set the path that we've defined previously. We're going to set our connection to the one I've just created. And content we're going to get because it is a read. That's what we would like to test. Next, only other one is action. And we'll set this to a read as we want to check that there's data coming back. There we go. Now what we'll do is we'll actually invoke this node. So we'll call this instance and invoke. And to determine if it was successful, we'll add an assert. And what we want to check is that this actually did come back with some content.
Just put a break on the...
Thanks. So here we'll just check the actual file demo instance and check that the content is not empty. Okay, so to do this, we'll just run it via debug. There we go. So I'll just run Control RT in there. Okay, stuff should be happening here at the bottom. Okay, so now it's building, it's going to run this test. And we'll see at the bottom here, it did discover test. Might be a bit tiny, that. Okay, now you guys can see it broke in there, and we did invoke it. So if you hover now over file demo content, you can see we've got a hello world going. So we're pretty happy with this. We can now check to publish this into the Flowgear console. To do this, we'll start by creating a release build. Just need to ensure, like we mentioned before, that the name is unique and that the version is unique as well. So I'm just going to create a release build.
Did you bump this version?
I did.
Okay.
Okay, then we're going to do a rebuild right there. And that has succeeded, as you guys can see over here. So now we can come up to our console. Just want to add again.
So we're basically going to take the build, the release build obviously. We're going to zip it up as a zip. We're using Windows zip, not WinRAR or anything, please. It's not going to recognize that. And then we're going to actually go through to our console, at which point we'll go to the node section and actually upload it. Now, you have to have the appropriate permissions within Flowgear to be able to do this at an account level. And so effectively, we're going to pick that file and upload it, and then we'll do a refresh on the list of nodes where we expect to see that node appear in the list.
So now I'm just navigating to the release build. I actually did not zip it yet, so that is a problem. Basically what we'll do, we'll zip the contents of this entire file. I'm just going to do that. So here, I'm just going to compress that straight up. Great. Now over here, we can select this zip we have just created.
Don't forget your account. You got your account, don't mind.
And let's see if it publishes. Great. Now the node has been published, so if we just refresh, we'll check the file demo node here, and we'll see the version has increased.
There's a distinct difference on global nodes. You'll see on the top right there's update nodes. That's going to be for you as a tenant to click on that and check if we've published new nodes from our side. And then it's going to tell you what's new and if you'd like to actually pull it down to your tenant. So it's kind of like a watch the space for new nodes.
Exactly. Okay, great. So now I'm just going to pop this new node onto our canvas. Just going to refresh it as well. Make sure it's the latest stuff. Okay. So as you guys can see, we have a file demo here that corresponds to our version. What I'm also going to do now is create a new connection.
Notice how these properties are exactly the same as the ones we declared in the project. Those are the ones that were decorated. You could have declared ones that didn't have a decorator for reasons of storing potentially timeouts and other important information, but it wouldn't surface on the console at that point.
Okay. So with this new connection, we can see now we have our different environments, as Nick and Carl mentioned earlier. We're going to select a drop point as we want to read a file from our local file system. So I have one prepared. And then we're also going to set our connection, create target directory. Okay, once that's been created, I'm just going to hook this up. Now we just need a path to read it from. So I'm just going to use the same path I used in the test earlier. And now we can run it, and let's see what happens. As you guys can see, it was successful, and the content being passed back, you can see, is hello world. And now we can also do a write as well with our target directory. So I'm just going to basically, I know this target directory doesn't exist, so I'm just going to say new. So we have this target directory set to true. And then that's our content, but this is a file, so it can be any file. It's just for very simple for our demo purposes. Now you guys can see it was successful. It says it has written it. To confirm, we can just switch this over back to a write and just confirm that the content being passed back, which would be on your output side, is also correct. And to confirm, to make sure it's not like hard-coded or something, you can just see it says create target directory. And yes, that is the basics to building, testing, and deploying your own custom node. This was a very basic example, so we're just going to hand over back to Nick now to move through a more complex scenario.
Yeah, cool. So the first thing we'll look at, oh, sorry, go ahead.
Yeah.
Nice, Rick. All right, so the first thing we'll look at is how you can interact with the Flowgear console in other ways, except for your invoke methods and your properties. There are additional places in which you may actually have to get data to and from the project or the console. One of those ways is the connect your account button, which you can see on the screen there. That's actually supporting an OAuth 2 process. So what happens there is you click the button, it redirects you to 0 in this case, the 0 login, I believe. You're expected to log in, and then the redirect back will then save those refresh and access tokens, which would then continue to be used as part of your credentials. Now, where this is actually surfaced in the console, the project itself, is through the interact method on the project. So this is basically a node project, which is way more complex. And in this particular space, we have an interact decorator, which says to us, if you click that button on the console, then this is what needs to be invoked to produce whatever needs to happen here. Now, it's surfaced purely because the interact is there, so if it wasn't there, it wouldn't be shown on the connection. And then at this point, it's going to kick this off, which, again, it's just an OAuth 2 process. But other stuff could be happening here as well. For example, we have a different kind of interact called refresh metadata, which in some of our nodes, like our REST request and our SOAP request node, allow you to specify URL for your target documentation. And you can click the refresh button, and it's going to pull those down for you, and that's actually going to generate samples, which is probably a good time to go look at samples now.
That is a good.
So those things that you guys saw when we went to the options and say choose sample, and you can pick all the actions, we're actually generating those, right? The way we generate them is dependent on a lot of different ways in terms of what the vendor can give us. One of the very common ways is an open API definition. And so what we will do in that case is we'll take the open API definition, we'll embed it as a resource, like a JSON or YAML, whatever it is. It'll be embedded as a resource, and then we'll use the Open API library to actually convert it into an API object, or an Open API object. We can then inspect that and start pushing it across into our samples. And so there we'll populate the description and the name and all that kind of stuff, as well as your response and your request payloads. There's a lot to get into here. The most complex part of this section is really just how you're going to generate your samples. But assigning your property values is simple. So once you have all that, you can just say, this is my description, this is my response payload, and then when you click on it, that's what gets pulled into the console. Then we can also look at some authentication.
Authentication, yeah.
Oh, actually, no, let's look at error handling for
success factors.
Yeah, let's look at that.
Got it.
So error handling is something that needs to be done in a very explicit manner. You can kind of capture a broader error, and you can provide it to the user, but what you need to understand when you're building a node like this is the whole purpose of Flowgear is obfuscation, or rather abstraction of complexity. So you can't just surface what's coming up directly onto the console and hope that people understand what they're seeing, right? So there's a very deliberate type of error handling that you need to include, where you kind of layer across what's potentially happening. Now, if you have a look at this, what's happening is we will, it's a web-based API, SuccessFactors, for those who are not familiar with it. And as we go and make that web call, we actually see if we can catch a web exception. Now, we don't just say, okay, we got a web exception, let's just throw it. Then we check, is the web exception actually got content? Does the web exception have content? Yes, it does. Cool, let's inspect that content. So now we see, is the content type text plain? So we're getting closer to where we're getting to the point where we can say, that specific code, that LG or whatever, that's a code, that's an error for an authentication problem, which tells us we need to redo the refresh token. There's a very explicit type of error handling that has to be put in place, and it's only in sort of the worst of times where you surface something very generic. And the big no-no is obviously object ref null errors. So for instance, a lot of testing you have to do is around someone just invoked the node. Did you check if the guy even put a URL in the connection? You have to do things like that, right? So that's the kind of breakdown of error handling. Anything else there, Rick?
Yeah.
You wanna
No, I think you covered it pretty
just
decently.
check. I've got,
Yeah.
I think, maybe one or two more things to touch on there.
We can speak about the configuration.
Configuration.
Yeah, exactly.
So there was a question earlier on about limitations and how you actually impose those limitations on your node, right? And so if we can first go to the console to show where that's set, there's a section on the advanced section for connections, which actually allows you to put in drop line, offline timeouts, normal timeouts, and even max data size. Now, the way this is then surfaced on the console, on the project, is on instantiation of the object, we actually go and use a configuration decorator to populate a dictionary of string and object. And so when we do that, what's actually happening in the background is the engine is saying, listen, I have these settings, let's pass it along to the project, and then we use the setter over there just to also go and move that into global variables. So our timeout seconds is actually going to be used in our web request to say, this is how long you're allowed to run before you can time out and move on. And so you can pass those sort of instructions down at that level, and that's how you would interact.
Okay.
I think that's about all we can really show for that. Ideally, what we wanted to show you first of all was obviously the node build itself. So what the foundations are and how it looks like and how you can publish it. We'd love for you guys to play around with it and actually start doing some of that. And then obviously as well some of the more in-depth aspects of this development or areas of design such as you saw here. So yeah, welcome to take any questions you guys might have. Go ahead.
So if you want to expose maybe your own APIs or your own systems to the platform, the only way to do it is through a node development.
Not necessarily. So for those that didn't hear, the question is if we wanted to expose our own API, how would we do it? It's not exclusively through node development. If you have an API that's complex, so it uses an SDK or something, then yes, you'll have to use node development because we have to consume that SDK. But under the assumption that your SDK, your API is simply web-based, you can use our generic connectors such as our REST request, our SOAP request, and our web request, which is just a generic form of consuming those APIs. So that's likely what road you'd go down. Yeah. So it doesn't have to be this way. But again, there is advantage in doing that because you get to brand your API and have it on the marketplace.
Any type of maybe open standards that you must adhere to your APIs?
Yes. So for REST request, if you can generate an open API definition according to the open API def specs, that's fantastic. We can consume that directly. So in the connection, you can just import that definition and it's going to generate samples. Otherwise, you can do WSDL, a WSDL document for XML, although that's not really, that's kind of old school. But if you have that kind of API, you're welcome to do so. Other than that, not really. The web request works like Postman inside of Flowgear. So there's a bit more effort involved, but you can plug in the URL, you can plug in the headers, you do everything yourself, basically. Anything else? All right. Go ahead.
Will any of the existing nodes be made available as examples or samples elsewhere that you can use as basically a template or to learn from?
Yeah, so we've provided our projects in the past. Obviously, it's not going to be out in the public, but if you have a use case you want to build something against, we typically give you the next closest thing that we've built so that you can work off of that. We don't really, it's not like, oh, this node is IP and that we can never let anybody see it because it's fairly straightforward. But yeah, if you ask us, we can get you a sample that's relevant to what you're trying to do.
So for licensing of nodes built on Flowgear, how does that sort of work? If we build something that's really useful, and then you're looking at it going, wow, we should have that in our system.
Well, we can't really see it because when you upload those libraries, we don't have the the source project for it. So we know that it's there. I guess we could inspect it backwards if we really, but we're not going to do that, right? So if you upload your own node under your own account, that's yours, and we don't have visibility of the source project. But if you want to make it public and publish it, at that point, I mean, that's it, right? It's on the platform publicly. So, yeah. Go ahead.
Any plans for continuous deployment?
Would you expand on that if you don't mind?
We connect our Git, we publish to our Git calls through to
Okay. Well, yes, actually, we have that because we have the global node repo. That's effectively what's being.
Well, yeah,
you can explain
we have
that.
it. So our global node repo, we actually store our like assets of our global nodes on a storage account in Azure. So we continuously deploy that by doing the update, pulling the node definitions from that store, publishing it into the new the tenant's actual store as well. So
Yeah. Sorry.
so that can be leveraged. So we can look at in the future doing that into GitHub as well for your guys.
Yes, that's the only missing link is the fact
Yeah.
that we need to take that thing and put it in our global repo. But we are actually looking at ways in which the moment that a merge has been done on production, that's exactly what's available. Yes.
Exactly.
We actually have that for the other aspects of our platform with like pushing versions of our platform out. It just happens to be the nodes that we haven't done that exact thing with. But yes, absolutely. Cool. Anything else? All right, guys, thank you so much. I really appreciate that. Again, we'll be available later on for any questions if you guys want to get deeper on the stuff. Otherwise, thank you so much for your time.